Hi, I have LeetCode. I'm making this video for my one of the new project that I have built, just like X. So I'm making my own series of projects just like X. So previously I have built a few projects under this series. I have built a project just like Twitch. So that project is named as ProStream. So this is a low latency live video streaming project. And another project I built just like LeetCode. So in that, everything the project I'm telling right now is the backend solutions. So in the next backend solution is just like LeetCode backend solution. So in the just like the project name is Alpha Code. So what Alpha Code does that it takes code in C++, it executes the code in a secure Docker container, it then evaluates the code and changes the result, just like what LeetCode does. Without no third-party API calling, build everything from scratch. Now, this is a third project in this series, just like X, that is just like YouTube. So CuteTube. And name is really cute. Okay. Um, so the QTube, what QTube does that this is a backend solution for any VoD platform that we use day to day. And one such very popular VoD platform on this planet is obviously YouTube. So this QTube project tries to mimic the backend solution, how actually what goes behind when a user actually uploads a video uh, when a video is file is requested by client to the backend, how those files are being served. So, and these two things I've tried to focus, and YouTube does same. It tries to implement, it tries to accomplish this main two feature of any beauty platform. So in this video, I'll try to make this video short, and this is the repo of this project. So before I go to the demonstration, practical demonstration, I would like to tell you a bit more about the project. So this is a repo you can see, and I have added a extensive, a detailed README in this project, so you can understand what is actually happening, how things are actually going. So everything I have, added it here in detail, so you do not have to feel lost if you really want to understand the project. So if you interesting thing I would like to tell you here within 1 or 2 minutes that I have used Django as the backend, and I have used a robust Celery pipeline. I have tested the pipeline very extensive amount of time I have invested to just test the Celery pipeline works as I expect, and S3 for storage, FFN for transcoding and segmented the video files. And for CDN part, I usually use AWS stuff, but what I tried this time that I wanted to test some different other than AWS. So I chose Chico CDN, and I must admit the CDN was really very fast, just like AWS. And um, for your information, the project has four versions. The first version you can see here, the first version is just the backend itself is serving the video file by chunk by chunk. The second version is manually running the fwing command and serve the segments. The third version is I have automated everything with a Celery pipeline. Everything. We just send a video file with an API, and that's all. You will instantly receive a video ID and some other metadata, and everything will be done background in the background. So no headache of the server. Everything will be uh, handled. And the fourth person is that I tried to implement DRM and um, dynamic watermarking in the segments. So I'll be very honest here that I have not found any. free version or free or trial version of any DRM server, as I thought I would get, but DRM server was, I thought there are few players in the market, but they do not actually accept any personal account. I have to sign in as a organization, so it is not possible to get a really DRM server. So I also tried to implement a DRM server on my own, but I ran out of my servers. So there is also a lot of tasks to implement. I really tried to my own DRM server, but then it was a lot of tasks and it was, I was actually shifting from my own actual target. So that's why I abandoned that. Then I found a free Microsoft server, the DRM server, test server, but that was not also working as I expected. And I need what I understood that I need some front end collaboration to actually implement DRM properly. So as I'm specialized in backend, so but I even tried with the Saka package to actually encrypt the video segment in the fourth person, and we tried to actually test it with Reddit TRM, but it is not working as expected. The TRM server is also malfunctioning sometimes, so it is under development still. But the third version, that is in a fully automated Celery pipeline solution, this is actually well tested. So I can see with a DRM, but how video segments or upload these things could be done. So one thing for your information that this version is actually a monolith version, but I am in the making of this project in microservices. I have built a few other projects in microservices, and I love microservices. I don't know why. Okay, so I'm also trying to implement this project in microservices, and there are a few I need some fine tune the microservice version, and then that will be done. Okay. So, and you can see there are a few rate limits in the two API that are primarily actually important in this project, that to get the metadata, to get the data where URL, where CDN URL actually, it is also rate limited, and the post request where to upload the video, it is also, you know, rate limited. And the rate limit I implemented in token bucket, and but in the microservice version I have implemented it with in constant window algorithm. So I hope so we can and this is fully Dockerized solution. So if you want to play around with the project, you just need to close this repo and make a virtual NB, CD to source, CD to source, and you just need to make Docker up uh, based on the ENBs you have to fill. That's all you need. And you have, I have also added the video in YouTube so that you can watch this um, QTube in action. And one thing I'd like to show you the HLD of this project. So here I have already uh, opened the HLD. So I'll try to understand how things are actually working. This is the fully backend solution. So things begin from the authentication. But before that, I want to tell you that QTube, I tried to make sure I actually um, mimic the functionalities of YouTube, core functionalities of YouTube. So I tried as I worked with this project that streaming part and upload part. My core focus was I would allow the user to stream and I would allow the user to upload. These are my main focus for this project. So as YouTube does not restrict users based on authentication, they are authenticated or not. So in QTube also, no authentication is needed to um, stream the video. And but to upload video, you need to be authenticated. Otherwise, you cannot upload a video. So things start from user, and user goes to auth section, auth API, and it uses a PG data database and Postgres database. And you see this very straightforward, and authentication is done. Cool. And now this is the stream video, how stream is working. When a user wants to stream, it actually sends a GET request with a video ID, the video it wants to stream. And what is stream API then backend does that it fetches the database, and from the database it actually returns the metadata, video metadata, and the serial URL to the user to the client. And then the client, the gas player, what it actually requests the serial to get the segments. And serial is a GPO serial, and S3 is used as the upstream of the serial. So the gas player actually sends a request to the serial, and serial then returns the MPD and the dash segments to the client, and the video so on is shown. So this is how the stream works. Now let's go to the how upload works. So this is the API upload API. When a user wants to upload a video, he sends a post request with some video metadata and a video MP4 file, and it goes this part, this section. So here, this is the where a Celery pipeline works. So in this section, there is a manager Celery pipeline, child Celery pipeline, and manager task, some managerial task, then some sub tasks, then some child task. So it has a very, robust Celery pipeline. A Celery pipeline inside the Celery pipeline, it has again Celery pipeline. So it is a very long chain of tasks. So the tasks that are subordinate will are designed to only work when the task uh, of his upper side is done. So this is how it is designed. If the any previous task is failed, then the downstream tasks are also failed. So if a video is failed to segment a video, then upload will not work. If a video is failed to transcode, then segmentation will not work. So this is how it's designed. So if a upload is failed, then cleanup will not work. So yeah, cleanup will work. Will definitely clean up. So this is how actually you have designed. So it is very complex. So now I just want to show you the overview of the Celery pipeline. So when a user actually sends a video, it gets to the backend with the upload API, and then before yeah. So Celery pipeline, I want to tell you here that YouTube only works with MP4 and API MOV file format. So otherwise MP4 MOV because I have to work on more for other video container. So right now I am actually working with MP4 MOV containers. So the video takes the API takes the video, and it asynchronously returns a response to the video ID and the message that upload started. That's all. And this API then activates the manager Celery pipeline. That is the core entry point where the Celery pipeline works. So when the Celery pipeline, the entry point is activated, then now this is Celery pipeline. You can say this is the manager for what the entry point of Celery pipeline, and then the first task of this chain is transcoding. We need to transcode the video. So because if the video is MP4, then the pipeline will transcode the video into MOV. But if the original video is MOV, then the pipeline will transcode the video into MP4. So then the first task is to transcoding the video based on the original extension of the video. Once the transcoding of the video is done, then the both file format, the both video will be segmented. So once the transcode is done, then the next step of the Celery pipeline is to segment those videos. So here, both video format will be segmented and segmented with ABR technology, adaptive bitrate technology, so that uh, user doesn't have to worry about the network condition they are actually using. The video will be segmented in 360p, 480p, and you can see here 360p, 480p. Yeah, 360p, 480p, 720, and 1080p pixels. with 800, 1200, 2400, and 4800 kbps bitrate. So all the both video will be segmented based on this four containers, four bitrate and resolutions. Once the segmentation is done, then all the segments will be grouped into some batches. The batches will be of size of 10. So all this 10 size of batch, all the segments will be taken in a group of batch. The batch size is 10. Then again, this will be a Celery task, and on by one, these batches will be will be created another Celery task inside pipeline, and these batches will be uploaded to the S3. So what I try to do here is that why I'm using batch processing here, because I wanted to offload the load of uploading the video, because it is a network call, right? So anything could happen. So what I tried that I do not rely on only one worker to upload the video. So I uploaded the uploading process to all the available workers in this right now, and create a small batches and then upload the video. So all the worker are actually and working. All the worker get their own S3 client, and then they actually upload the segments to the S3 bucket. So no worker is actually overwhelmed with no worker is actually responsible to upload all the data by itself. All the worker who is available, once available, will try to upload the data. So uploading process is not bound to any particular worker. It is uploaded to all the available workers out there. And once all the batches are processed to upload the video, only then, as a callback, the video cleanup process will start. Uh, it is a callback, so I made sure that callback will only callback will only activate it when all the code is complete. Then the local files are cleaned up. So this is actually microservices solutions, and then an event is generated. Uh, you can say this is a microservice part, and this is another service. Then an event is generated. Then in the microservice solution, and then this is another app. This is stream app. So it will consume the event that the video processing is successful. Then it will actually update the database with the data with the necessary metadata. Uh, the this service will pass to this event. Then all the metadata regarding the video, the path to S3 or the GCO CDN URL, everything will be updated here. And user will be notified with email or some other means of communication, or maybe with a notification that the video upload has successful. So this is the microservice solution I'm yet to implement, but in monolith this is not implemented, but in microservices this will be implemented. I'm making of this. So as you have understood the mm, high level understanding of the YouTube, now let's actually show you how things are actually working. So this is my mm, Postman. So now, okay, let me show you the Docker. So you can see here a few containers are running. So you can see this is the Nginx for proxy, and this is the backend API, the Django. This is the Celery, and this is the Flower to manage or monitor the Celery, and this is the PG database, and this is the Redis for caching or some other stuff. And if I show you here, you can see these are core apps. This is the V3 I'm talking about, and this here are the all the tasks. But this is so many tasks, and so you can see I have added a really good amount of documentation, so it will not be very much difficult to understand what is happening in this. I have also added a good amount of logging to understand what is happening in which section of the working. So you can really, it's not possible to explain the code, but if you go through the code, if you want to contribute, then go through the code, read the uh, documentation, you will easily understand what's happening here. So now let's jump into the active how QTV works in the behind. So you can see this is the I have YouTube Celery. So I am watching the how much resource is taking the YouTube Celery worker to process all this video, because this is why I was unable to actually deploy the video, because depending on the video file size, it is taking from 3 GB to 8 GB of RAM to process the video. So because I am only using some free AWS server, so and free AWS server only 1 GB, so it's not possible to deploy this project, you know. So yeah, I only need to show you on my own desktop, because I have 12 GB of memory, so it can handle. So this is the log for the backend solution. This is a K2 API, Django backend. This is the Celery logging and the Celery resource. Yeah. Okay. So now get the video, all the video. I'm sending a request to the backend. So you can see there is only one video right now. You can see this is the metadata and this is a pagination response. You can see this is the MP4 is 3 MPD URL, MP4 is 3 S3 version URL, and you can see this is the Chico CDN URL, cdn.algocode.site. Yeah, so one thing I'd like to tell you that I already mentioned that I have built a AlgoCode name project, and to build AlgoCode, I actually bought a domain algocode.site. So I use that domain actually to make the CDN domain for Qt, and this is the MOV version of this is the MOV version of the Chico CDN URL. So you'll understand what's happening here. Just a meantime, and this is the MPD URL. So it has using this URL actually this API. Any client can get all the metadata. This metadata actually, this metadata is being sent. This kind of metadata is sent for with this API actually. You see, the video ID is not correct. Okay, cool, no issue. And this is the upload URL. This is how where all the magic happens. So okay, so let me show you the. This is the flower. There is, you can see there is no task right now. Okay, and this is the backend. You can see this is the video metadata. This is the video database, and you can see this, there is only one video. And okay, so now let's just send a request, a post request. It is a title, description, this is the database, this is a video. Okay, so now send a request. No video. Oh, okay. I need to select the video again, I guess. So I need to select the video again. Here, yeah. So I've selected video, and now I'm sending the request. And okay, rate limited. Oh, acha. I only made a single request for 20 seconds, so this is the rate limit activated. Okay, but no worry. I have already cached this for 1 minute only, so I don't have to wait for 20 minutes. For this purpose only, I actually cache this data for 1 minute, so that I don't have to actually wait for 20 minutes. So I need to check. I need to wait few more seconds, and I will be able to send a request. I guess I can send now. Yeah, you can see I have just received some metadata, and I can go here, and yeah, the backend tells backend is free, backend is not busy, and I can see, yeah, the Celery pipeline is already activated and it is doing job. You can see I have logged some, I have really made some extensive logging so that we can understand what is happening at what stage. We can see transcode video. So transcode video, I already told you here. Video transcoding is the first task in the Celery pipeline. So transcoding is actually activated. Dash pipeline entry point. Transcode details. Original video is this one. So this is the original video. This MP4 to be transcoded to MOV. You can see. So original video is MP4. So it will be transcoded into MOV. And segmentation is 3 upload and cleanup are waiting. Cool. Now let's see. You can see the transcoding part is actually ongoing. What I can do that I can pause this video here because it will take some time. Meantime, I can show you the stats. You can see for the transcoding, it is almost taking 500 MB of RAM to transcode the video. So it is a 34 seconds of video. So it is taking 500 MB of RAM. So you can assume that if only the Celery pipeline is taking almost 900 of MB of RAM and AWS server only gives a 900 MB of RAM, so I really can deploy. I have to purchase almost I know anything uh, greater than 4G of server to deploy this pull. So this is not feasible for me right now. So that's why I must show you using my local PC, my Linux machine. I love Linux, by the way. Yeah, transcoding is still ongoing. So I think okay. Transcoding is still processing. I think I should stop the um, video, pause the video, and then I'll be back. Okay, so transcoding part is not yet done, but let me tell you some information about what is actually how I am using FFmpeg here. That I am actually transcoding it to I'm using uh, Dash here, not HLS. I'm using Dash, and I'm using H.264 as encoder. And because H.264 is widely used, and the output file is not that much large for H.264, and uh, I've seen few advantages and disadvantages of H.264 or H.265, but H.264 I think is lighter than H.265. And you can see this is a container resolution for 180p, and this is a resolution for 70dp, and this is a resolution for 480p, and this is a resolution for 360p. Okay, so this is actually uh, transcoding is transcoding still transcoding. Yeah, okay. So I think it will take some more time. No, I think one sec. Acha, sorry. Transcoding was already done. So segmentation is actually those are segments. I misunderstood. I also thinking these are the segments. Yeah, these are segments. It is not transcoding. So transcoding is already done here, as I can see. Yeah, transcoding is already done here, and you can see that yeah, dash transcode video success. So transcoding is already done, and you can see the mp4 file transcoding is already success. And then the entry point, this you can see, as I told you, that there is a main Celery pipeline, and inside the main Celery pipeline transcoding is standalone. Then another sub Celery pipeline is there, and in another Celery sub pipeline there is a another sub manager who actually manages those sub Celery pipeline. And this dash processing entry point is a sub manager who actually oversees all the segmentation. Uh, then segmenting, then actually uploading those batch processing, uh, then actually clean up the files. So this is how it is actually designed to make it less buggy and error free. And you can see the login dash processing endpoint. Segmentation is 3 upload and cleanup is about to start for video file. You can see for MP4. For MP4 file, dash segmentation is actually started. And you can see dash processing entry point. Segmentation is 3 upload and cleanup is about to start for video file MOV. So for the both MP4 and MOV file, all the segmentation on all the stuff. So as I told you, this entry point actually activated for the both video file, and for both the video file everything will be handled by different their own Celery pipeline. So their own all the video file will have their own Celery pipeline, and they will go, and it is like uh, for the all the video they have their own individual actually pathway of segmentation, history upload and cleanup. So they are not actually jumbled into all the videos. So the MP4 file will go through this way and the MP file go through this way. So there is no in between those files. They are standalone and independent. So there is nothing collision between these files. This is how this is actually designed. And now you can see the worker 2 actually took this, and now you can see dash segment video started. So dash segmentation for video file, this MP4 video file for segmentation started, and the same time the segmentation for MOV file is also started. So it was actually not I couldn't understand that time. So now you can see the segmentation. Yeah, so segmentation started, and excuse me, and you can see. Yeah, so this how I already told you that I am actually segmenting as a adaptive bitrate. So for this 180p, I'm taking 4800 kbps. For the 720p, I'm using 2400 kbps, and for the 480, I'm using 1200 kbps, and for 360, I'm taking 800 kbps. And this is adaptive bitrate. And I am using H264 as an encoder for the video. And the container is MP4, and other container is MOV. And you can see, and for this is for MOV file. You can see the MOV file. MOV file. It is MOV file also segmented with what adaptive bitrate. It is also being segmented to 180p, 720p for the same thing. It goes the same way. You can see, and the same H264 encoder is also used in this also, and you can see the segmentation also started for both parallelly is happening. MP4, you can see MP4, 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 and now you can see the MOV, 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 MP4. So parallelly, the both video is actually being segmented uh, in adaptive bitrate technology, and you can see the segmentation is working, and you can see the dash segment video success. So dash segmentation is successfully, and you can see once it is a success, a worker is freed at this time, and another as I already told you, this is a pipeline. So once a task is completed, the latter task, the subtask or the child task is being activated. And now you can see upload dash segments to S3. So this is the latter task. It is received, and you can see here a few logging things, and I am actually taking this data for deciding whether to proceed with the ladder task or not. So using this data, I am actually deciding inside the Celery pipeline whether to actually proceed with this task or not. You can see segmentation is successful for you can see segmentation is successful for MP4 file format. Okay, so for MP4 file format, the segmentation is done. You can see as the MP4 file format segmentation is done, you can see main dash segments. So inside the Celery pipeline, there is also another subtask that oversaws the uploading purpose. This main dash segment task is actually responsible to making those segments into batches. It will actually generate a 10 side batch. Then all those batch will be again created as a task. Then all those tasks will be actually offloaded to all the available workers, and those worker will actually get their own S3 client, and they will actually upload. So all this upload will be actually oversaw from this task only. So it will be the manager for uploading the task, making the batches for the segments and creating the batches. You can see for this 34 seconds video, I know that there is 34 second video. I know there are 34 segments, and one is empty file. So you can see, as I already told you, a batch is created with 10 segments. So you can see there are four subtasks is created. Three for 10, 10, 10, three tasks, and four is for another task is with four segments and one empty file. So there are four subtasks is created by this main task. So these four tasks is child's subtask of this main task of upload file. So these are the batch processing. Okay, you can see the S3 upload progress. This is the 10 of one video. I have also added how much the progress is actually happening of the upload. So on of 10 of one video is uploaded, 10 of one video. So you can see this is the 10 of one video. This is sorry, one of 10 videos. This is one of 10 videos. So all the four, I think, worker is actually um, working. I think so, to upload the video. And you can see, yeah. So I know all the not, maybe two worker was free, and two worker is actually uploading the video at this time. So we can see here. Then you can see S3 upload progress is 50%. Now it is actually, let's see, and I think the MOV. So you can see the MOV segmentation is done at this time, I guess. Yeah. At this time, the half of the MP4 segmentation is already uploaded, and half of the MP4 segmentation is actually created a batch of 10 segments. Then they are actually overloaded, uploaded to all the idle workers. So no worker is actually, sitting idle. I am actually using all the workers. So if I used to, what you can see here is that MP4 MOV segmentation is now done, and you can see the two worker was free at this time, so two workers actually started uploading. So what if I did not divided those segments into batches? That then only one worker would actually upload this video, and another worker would sit idle, right? So this is a waste of resource. So that's why I am making these batches, so that no worker is sitting idle, and the process is actually much faster, and I am utilizing the full potential of the server. So this is why I'm actually uploading this. And as I know that this is a Celery is thread safe, and this is a process based, but it's still I have tried to implement a singleton class here. But I know, but still I have tried to I have implemented singleton and for the S3 client. So that's how I'm actually utilizing the full potential for of this workers. As and the MOV segmentation is done, you can see the MP4 upload is almost completed. MP4 upload is almost completed. You can see. So segment S3 upload, segment batch upload success. You can see. Now you can see that main dash segments. This is for MOV file. You can see. Uh, you can see this is the for MOV file main dash S3 upload started. So again for this MOV file, again there will be a four batches. You can see this is the four batches of four tasks with all the tasks are entitled to upload for one batch, and all the one batch has 10 segments. Sorry, three batch has 10 segments, and one batch has only 5 segments. Now we can see mm, uh, you can see the upload for the MOV file is started, and you can see the upload for MP4 file is succeeded with 9 seconds. And this is the upload for MOV file. And you can see the upload for MOV file is actually ongoing. And once the upload for MOV file is ongoing, now you can see that batch segment upload success. And you can see it is succeeded with 8 seconds. Now you can see the segments upload is short code callback, validating segment upload status. So it is now as the upload is done, as I already told you, once the upload process is done, then only the local file cleanup will be activated. And now segment batch S3 upload success. So batch processing for the uploading to S3 is succeeded. Now once it verified that all the data are actually uploaded, there is nothing to worry about or loss any data. Then it is activated and segment upload S3 starting local cleanup files. Only then when it has actually verified that everything is uploaded, then it is actually activating to clean up the local files. Then video file cleanup success, you can see. And you can see again here segment of S3 upload progress. You can see 100%. This is the MOV file as it is actually started later. This is the MOV file and video file cleanup success is for the MP4 file. So you can see this is as I am utilizing all the 4 workers and I'm not, as I have actually uploaded all the workload to all the available workers evenly. So no worker is actually sitting idle. I have, as I have uploaded the workload to evenly, distributed all workload to evenly to the all workers. So the no worker is actually responsible to complete any individual task on its own. It will be actually assigned a small amount of task and it will finish it quickly. Then again, another task is waiting and it will actually take up the task. Instead of assign a long task to a single worker. So what is the downside of this doing such way? That if I assign a long task to only one worker, then there might be not all the tasks are very long, right? So there could be some tasks that are not long, and so all the short task will be completed, and then that task will be that worker will be sitting idle, and the another worker will be actually going on with the long task. So instead that I have divided broken down all the tasks into some subtasks so that no worker is actually overwhelmed by a long task. So they are actually doing all the things evenly. So you can see a worker is actually deleting files and another worker is actually uploading the MOV file, MOV segments. And segment batch upload success. This is the MOV upload success, and the batch processing. And you can see again it is actually uploading. As you can see, this is one batch upload success and again S3 upload progress. So as I already told you, so those workers are assigned short task. So one worker actually uploaded those batches. Now, as this worker is actually this worker three is actually successful with this batch. Now it will take any available task. So it is actually freed right now. But other tasks, you can see other worker, it is actually uploading a batch of, and it is done with 80% of each task. So this is how I am efficiently managing the resources so that I can actually make the all the background processing faster than assigning a long task to any worker. Now you can see the worker 4 is actually segment files. It is actually cleaning up the files. Once the cleanup is done, then worker 4 is telling us that you can see here MP4. Yeah, you can see the MP4. MP4 file format is actually processed successfully, and still you can see worker 2. Worker 2 is now uploading 90%. Worker 2 is actually uploading 100%. Now worker 2 is telling segment upload successful. Worker 2 now telling that it took 8 seconds to upload. And then you can see worker 1 is still uploading. It is done with the 60%. You can see five segments only, 4 segments and one MP3 file. and worker one is actually uploading, worker one is still uploading, worker one tells that upload success. And then you can see the worker 4. Worker 4 was doing here is the deletion, as the worker 4 was actually freed here. Worker 4 was freed first. Then worker 4 took again the available task. As it is received a task, worker 4 took the task. And what is the task? It is the task of the hmm, uh, task of the clean up the local files. So starting clean up local files, video as it validated the local files that everything is okay. Then video and the MOV file actually deleted. It deleted the MOV files, local file. Then it then deleted the local segment files, and you can see that this MOV file format is also processed. So this is how the all the background things are actually working. You can see this extensive amount of logging, so that you can understand when and at which section, at which place, what is happening. And I have tried to efficiently utilize all the worker available, so that I can make use of every bit of the server, and it is not sitting idle. So as let's verify what is the video file name here. You can see uh, 13. This is the video file name. The 1368. So 1368 is the video file name. Okay. So 1368. Now let's go to S3. Okay. So this is my AWS account, and now go to S3. The video file you can see 1368. This is the bucket name, and this is the actually folder where the data are located. You can see 136 here. 13641 E5. 13641 E5. So this is the actually file name. So go inside this file, and you can see all the data, all the segments are divided into as per their container name. So for if I go inside the MOV container, you can see it has 35 segments, 34 segments for 30-second video, and one is manifest MPD file. And you can see the size, that size are variable, right? So this indicates that it is a complied to adaptive bitrate. This is I guess this is 720p, I guess so, or maybe it could be 480. This is obviously 360p. This is 360p, I guess. It could be 360p. 360p. This is 720p. Yeah, this is 720p. 720p. This is 1080p. This is also this 1080p segment. This is also 1080p segment. So you can see segments are actually adaptive bitrate. And now we can go to the MP4, and you can see for the MP4 it is also same amount of this is also file size is variable, and there is an MP4 MP file and all the segments. Okay, and we can go to the database and we can just refresh. You can see there is a two video file. Cool. So this is 31st July, and so this is the today's video. This is the today's video. Now, as I have already processed the video, now let's see how actually the video is being served to the client. So I am copying the video ID. As to play the video, we need the video ID, and I have actually very minimalistic MP4 dash player, very minimalistic dash player. What the dash player does is that, let me tell you. So it takes the video ID. This is the, I have to give the video ID here. Okay. So what it does that it sends a get request to the this API, that is backend URL with the video ID. And if it is a rate limit, then it actually tells the wait time. If it is not, then it actually finds out what is the client OS. If it is Windows, then it actually plays URL to set the URL to MP4 G-code CDN URL. Or if it is Mac OS or Linux, then the URL is CDN URL is to the MOV version Otherwise, by default, the MP4 CDN will be selected. And then this is the dash layer. You can see that based on the ways of the client, the you can see where yeah, you can see this is how the data is being fetched. The MPD file is fetched, then the video file, the segments are actually served. So now let's just go one line with this file. I think if you can see, ta-da! You can see the video. You can see this is automatically the segments are actually being downloaded here. Automatically the segments are downloaded. You can see, and if I play the video, you can see. Okay, just pause. The video is being played, right? So the interesting thing is that let me inspect it and show you how things are actually being solved. Go to the network and refresh it again, and you can see, yeah. So dash segments are being downloaded. You can see this is the chunks. These are being downloaded, and backend. Yeah, this is the backend API. This is actually the backend API. It is actually fetching the data with us correct video ID, and once the data is received, then you can see here the manifest file is received. The client actually received the manifest file, and you can see the interesting thing is that the manifest is received from the CDN. You can see cdn.algocode.site, and the CDN G-code CDN as previously told you. The CDN is actually playing an important role here, and the S3 is actually upstream of the CDN. So as the MPD file is being has received, and you can see this is the MOV file has been received, and as I'm using a PopOS, so MOV file is has received, and you can see this is the init chunks, and the segments are being served from the cdn.algocode.site. This is my custom URL. So all the segments are being served from the CDN. You can see CDN. I hope we can get it. So the rate limit, you can see the rate. This is also served, and this is also served, and this is also served. And again refresh. You can see this is not served. Photo 9. You can see too many requests. Now let's go to the console, and you can see wait time is 7 seconds, and it is served, and it is not served. Wait time is 30 seconds. So for part 20 seconds, I can actually make a single request. Wait time is 5 seconds. Wait time is again 1 second almost. So it is now, we can see, and the request is served, and if I, we can see the segment being downloaded here. I can play the video. You can see picture to picture is also working, and it is also as 20 second passed, so request is served, and now 20 second is not, has not passed. 8 second, 4 second, you can see 1 second, and the request is served. You can see it will be served. Yeah, now you can make another request. So wait time is 4 to 8 seconds. And I already told you, so this is the upload, so I do not want to upload again. So I hope you can actually understand. We have got a glimpse how this is actually working. I think you have, you can see this channel automatic download, and I'm using from the serial. So this is all you can, and to see the flower, you can see there are a lot of tasks. There are a lot of tasks. There are a lot of tasks, as I already told you. So I'm not going to in detail of all these uh, things in flower. So it was just I know the video is long, but I was needed to show you how things are actually working. So I hope so you have enjoyed the video. Thank you very much for your understanding.